All right, let's have a look at this one. So we've got 3 different parts to this trip. The first thing we want to do is write down all of our givens so we can get some idea of what this trip kind of looks like. Okay, in part 1, they're traveling north, and they're doing that for 1.1 hours. Okay, which, can I leave it in hours? No, my speeds are given, or sorry, my velocities are given to me in meters per second. So I need to convert the time into hours by multiplying by 3,600. Right, so I'll take that 1.1 times 3,600 and have it in seconds right away, 3,960. Okay, 3,960 seconds, and the velocity is 3 meters per second north. All right, and that's all I know for part 1. In the second part of the trip, they walked 7 kilometers south, so they gave me a displacement. And that takes them 1.5 hours. All right, so I've got to get that into seconds. All right, so looking at 5,400 seconds. And that's all we know for part 2. And then in the third part, they walk at 4.5 meters per second north. For another 2 hours. So that's 7,200 seconds. All right, so that's all the information we have. So they start out going north, then they turn around and come back south, and then they turn around and go back north again. Okay, what I've got to figure out here is, first off, the overall distance traveled, which, does direction matter for that? No. Distance is scalar, so I just need to figure out how far they walk. Then I'll need to figure out their average velocity. Does direction matter for that? Yes, it does. Okay, so first thing I'm going to do is calculate the total distance traveled. Now, in order to do that, I've got to calculate the distance in each part of this. I already know it in part 2, so I don't need to bother doing that. But I don't know how far they go in part 1 or part 3, but it's going to be the same calculation in both of them. All right, so I'm going to take v equals d over t and manipulate it for d. So I'm going to multiply both sides by t. Okay, and that'll be the formula I'm left with. All right, so that will mean 3,960 times 3 meters per second will give me my displacement. So the displacement in part 1 is 11,880 meters north. Why did I bother putting a direction on that if I'm looking for distance? Well, not only is it in the equation, but I'm also going to need that direction when I calculate the velocity, right? Because I'll have to calculate the total displacement in order to get velocity. So I'm just going to leave it that way. In terms of distance, I just say it's 11,880 meters, and I don't put the n on it. Okay, no big deal. All right, I have to do the same calculation here in part 3. So displacement will be velocity times time. Okay, and so that will be 7,200 times 4.5. All right, so we're looking at 32,400 meters, and that's north. Okay, so they go, sorry, that wasn't enough. I missed a 0. I thought that looked, oh, no, it is there. Okay, so it looks to me like they walk a lot further north than they walk south. Agreed? Okay, so now I've kind of got a general picture of what this trip looks like in my head. First thing I'm supposed to calculate is total distance. So I'm going to take the displacement for each one of these parts and just add them together. Regardless of whether they were north or south, I'm just adding them because distance is just about how far the elephants walk. All right, so we'll take our 32,400 plus 11,880, sorry, 880, and 7 kilometers, 7,000 meters. Okay, so the total distance traveled is 51,280 meters. Okay, so is it important for me to remember which things are vector and which things are scalar? Yeah, because I calculate them differently, right? Okay, second part of this question wants me to calculate the average velocity over the entire trip. That means I need the total displacement and I need the total time. All right, now to get the total time is easy. What do I do with all the times? I just add them up. Yeah, okay, that'll be the total time for the trip. So that part's fairly straightforward. All right, so average velocity, okay, will be, we'll have our 3960 plus 5400 plus 7200. All right, that'll give us our total time. Now, to calculate my total displacement, does the north and south matter for that? It does. Okay, because now I'm not figuring out how far the elephants walked. I'm figuring out how far and in what direction are they now from where they started. Remember, they went north, then they came back south a little ways, and then they went north again. Okay, so they're further north than when they started. Okay, so I'm going to look at this. I'm going to say 11,880 meters. Okay, and then I'm going to add to that a south number. So I'm going to make it negative, or I could subtract it, whichever makes more sense in your head. Okay, and that south distance was 7 kilometers, so that's 7,000 meters. And then this last one here, okay, was north, right? So that's 32,400. So I'm going to add that one on there. All right, so all I'm doing with my directions is making them positive or negative, and that's all we'll have to do in Science 10, okay, is just worry about forward, backward, plus, minus. Okay? All right, so now that I've got that equation set up, I can calculate my average velocity. So first I'll figure out what the top is and what the bottom is. Okay, so we'll have 11,880 minus 7,000 plus 32,400. All right, so my total displacement is 37,280 meters. All right, and the total time, 3960 plus 7200 plus 5400. Okay, so 16,560. Okay, and it's important for me to put on there that that displacement is north. Okay. Now I can calculate my average velocity. Oh, 280. All right, so the average velocity of the elephants, okay, after all of this, is 2.25 meters per second. North. Right. Okay. I've given that question on quizzes and tests in the past. We used it as an example this time, but expect that you could very likely see something like that, okay, on a unit exam or a quiz. Okay, because all it's asking you to do is remember what things are scalar, what things are vector, and then perform some simple calculations. Okay, manipulate vehicles, d over t, stuff like that. All right. Questions on that one? Now, what I want you guys to do is just work on a couple of practice ones here for a little bit, then we'll take a break and we'll look at something else. But for right now, I want you guys to do 1 through 3 from this. It's also on Google Classroom if you want to have it on your phone next to you. It's in the class materials stuff. So if you go to Classroom, okay. And so you've got a class work. It'll be here in course materials for physics. Okay, and it's the one that says worksheet package. Okay, so if you open that up, it's the same file. Okay, so I'll give you guys a few minutes to work on 1 through 3. Okay, then we'll have a look at those together. Okay, so for number 3 here, okay, we want to separate it into the 2 parts. Okay, as well as our totals. Okay, so in part 1, they're traveling at a speed, actually it should say velocity, of 350 kilometers per hour east for 45 minutes. All right, so we've got a velocity of 350 kilometers per hour, and that's in an easterly direction, and our time is 0.75 hours. Okay, I'm going to convert that to hours so that my units for time match. Okay. In part 2, okay, we're going 375 kilometers per hour west, and doing that for a half an hour. Okay, so we're looking for how far the plane goes, distance-wise. So do I need direction for that? No. I just need to know how far the plane went in total. Doesn't matter that it went east and then came back west. I'm just looking for a scalar quantity in distance. All right, so I need to know the distance. Sorry, no, just the distance. Okay, and I did it again. Just want to put that arrow over top of that. All right, so I want to calculate the distance. Then, okay, it wants to know the what its final displacement is. So I got to have that as well. And what's the average speed over the entire trip? Okay. When I'm calculating the average speed, do I use distance or displacement to calculate that? Distance. Okay, and again, that's just one of those things we have to remember. The math isn't hard here. It's remembering which things I have to use in the math that can be tricky. All right, so what I need to find here, if I'm going to find total distance and total displacement, is I need to know the displacement in each part of the trip. All right, so I'm going to calculate that quickly by taking v equals d over t and manipulating it for d. All right, so d will equal v times t. Okay, and we'll plug in our numbers. So 350 times 0.75. Okay, so in the first part, we go 262.5 kilometers east. All right, and that east is still important. Okay, I need to know that direction for when I'm calculating the displacement up here. Okay, if I'm just talking about how far did it go, it just went 262.5 kilometers in that part. Same calculation here. Okay, displacement equals velocity times time. It's that this time it'll be 375 times a half an hour. Okay, because those are our times for part 2. All right, so 187.5 kilometers. And that's west. Okay, now that I've got those 2 numbers, now I can go back over here and get some of my totals. All right, the total distance, scalar quantity, I just take my 187 and my 262 and I add them together. All right, there's my total distance traveled, 450 kilometers. Okay, so I just have to remember that distance is scalar and not include the directions. Now, for displacement, now direction does matter. I went east 262.5 kilometers, then I came back west 187.5. So what do I have to do with those 2 numbers? I have to subtract them, yeah, okay, because I backtracked. I went out and back, or sorry, yeah, I went out and back a ways. All right, so my total displacement then is only 75 kilometers east, right? Because I went east 262 and west 187. So. All right. If I want to calculate the average speed over the entire trip, I need the total distance and I need the total time. right? So those two things I've already found the total distance, so I don't have to do any extra calculating for that. It's 450 kilometers, right? The total time, well, 3/4 of an hour plus a half an hour is 1.25 hours. All right, so the average speed of the plane, 450 divided by 1.25 hours. 360 kilometers per hour. Do I need a direction on that? Nope. I can't put a direction on that. I used one thing that went east and one thing that went west. I can't. Okay, this is a scalar quantity. Speed is scalar. Okay, I used distance to calculate it, and that distance didn't have a direction on it. So I can't magically just suddenly have a direction. Okay, the stuff I used to calculate didn't have any, so the answer can't have any. Everybody all right with that? Okay. All right. Give you about a 5-minute break here, and then we're going to try a couple more of those that are maybe a little bit stickier, right, and see how we do with those. Right, but you got a 5-minute break here. So if you need to go to the bathroom, check your snaps, whatever. For a question like number 8, don't be embarrassed about drawing a picture. Okay, and when we get into physics 20 and we start doing, vectors that are angled at compass directions and all that kind of stuff, we draw diagrams all the time. We draw a diagram for every single question in physics 20. So there's nothing wrong with drawing a diagram for a question like this. The question says they start in the northeast corner of the store. Okay, and they go up and down these aisles. Okay, they tell us that the aisles are 30 meters long, which actually isn't going to end up being important, okay, and 7 meters wide. That will end up being important. At the end of all of this, they're going to end up 12 aisles over, okay? So if they're going, here's one aisle, then they go up the next aisle, and then they go up, because I should number these, right? This would be like aisle 1, 2, 3. At the end, they go over a bunch of aisles. They end up over here. They end up over here. 12 aisles later, they end up due west of where they started because they went up and down 12 aisles, right? Now, since there are 12 aisles and each aisle is 7 meters wide, can I figure out how far over they are? Okay, so all I'm going to do is take the 12 aisles and multiply by how wide they are. So 12 times 7. Okay, they've gone 84 meters west. That's their displacement. Okay, that took them, what does it say here? It took them 35 minutes. Okay, so if I want to figure out their speed or their velocity, sorry, in meters per second, I just have to multiply this number by, it's in minutes right now. If I want it in seconds, I multiply by 60. Okay, because it's in minutes, not hours. All right, so 35 times 60. All right, there's my time, 2100 seconds. Okay, it went 84 meters, so 84 divided by that time, right? So this is displacement, divided by 2100. Okay, that's my time. I multiplied 35 divided by 2100. Not by 84 divided by 2100. I knew that looked wrong. Nobody says anything. Make me figure it out. Okay. All right, so they walked at 0.04 meters per second west. In other words, because they were going up and down, stopping, picking stuff and putting it in a cart, blah, 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 they only ended up going 4 centimeters every second in total, okay, in a westerly direction. Okay. Obviously, their total distance traveled would be a lot more than that, agreed? Okay. Then I would have to go, okay, so they went down this aisle, that's 70 meters plus 70 meters plus 70 meters. Multiply it, you'd go 70 times 12, okay, and add on the width that you went over as well. That would be your total distance traveled. Okay, question didn't ask for that, so we didn't have to do it. Questions on how that one works? Okay, how many people have done number 10? Okay, no more time on that one? All right, so there's number 10. Okay, I'll leave that up for a little bit here and then we'll go over it. Okay, so one of the points that this question is trying to make is the importance of not making assumptions. Okay, a lot of people just assume that the first baseman and the second baseman stand on their bases and throw the ball back and forth. Okay, but they don't. If you've ever seen a first baseman and a second baseman running a person down who's tried to steal the base, they get closer together, right? Like they throw the ball to each other and they move a little bit closer together because the person trapped in the middle can't run around them. He can't leave the baseline. Okay, so they just gradually get closer and closer together until somebody can tag him, and that's what happens here. The first baseman and the second baseman initially are standing on their bases 50 meters apart, but by the end, okay, that's not where they are anymore. All right, so what we've got is, okay, we'll say that second base is right here. Okay, and first base is right here because it says that the first baseman throws the ball due north at 25 meters per second. All right, so in part one, I've got a velocity of 25 meters per second north, and it's in the air for 2 seconds. Okay, and then in part two, okay, the second baseman throws the ball back to the first baseman, and he does that at a velocity of 22 meters per second south, okay, and that covers a distance of 30 meters. All right, so in this case, we know that the first baseman has run 20 meters closer to the second baseman in the time that the ball was in the air. Okay, and that's what we kind of have to get out of that question rather than making an assumption about what the first baseman has done. Okay, so first thing we want to find is what's the displacement of the ball? Okay, well, if I'm going to find the displacement of the ball, I need to know how far it went in part one. Agreed? Okay, so I'm going to calculate that by just going v times t, 25 times 2. Okay, the ball was thrown 50 meters north in part one. Okay, then it was thrown 30 meters south in part two. So how far from first base is it now? 20 meters north. Okay, because this person threw it, okay, 50 meters, and then it came back 30 meters. That means it's still displaced 20 meters north of where it started. Okay, so again, don't be shy about drawing a picture, okay? Especially if you're a visual person. Okay, represent this thing with a picture. All right, so our total displacement is 20 meters north. Okay, second part of the question is, how long is the ball in the air for? All right, well, I know the ball's in the air for 2 seconds in part one, but what I need to figure out is how long is it in the air in part two? So time, okay, if I'm going to calculate time, v equals d over t, I multiply both sides by t, I divide both sides by v. So t equals 30 meters d divided by v, 22. All right, so in part two, it's in the air for 1.36 seconds, plus the 2 seconds it was in the air in part one, and we're looking at 3.36 seconds of the total flight time of the ball. Everybody okay with what we did there? All right. And then the last part is, what's the average velocity of the ball? Well, the two things I need for that, okay, for average velocity, are total displacement and total time. Did I just calculate those two things? Yeah, okay. We calculated in part A that the total displacement of the ball was 20 meters north. And in part B, we calculated it was in the air for 3.36 seconds. Okay, so all I have to do is divide those two numbers, and I've got the average velocity of the ball, okay, which should come out to 5.95 meters per second north. Okay. Everybody all right with that? So it's a lot of words, right? Like, and the reason we're exposing you to questions like this that involve actually a lot of reading is because that's the trend on the diploma exams, okay? Especially the physics diploma. There are questions, and I kid you not, where people have to read a page and a half or more of text, okay? Like a story about an experiment being run, and then they're asked to answer 2 questions about it, okay? So you have to do all this reading and then answer 2 questions based on all that reading. Okay, it becomes more of a reading comprehension type of a test than it does, a test about how well can you do your physics. All right, so we got to be able to pull information from a lot of text so that we can use it. Okay, tomorrow we're going to be doing a lab. Okay, that lab is going to be on position versus time graphs. Right now, we haven't really talked a lot about position versus time graphs yet, but tomorrow is when I could get the Chromebooks, so we're going to do the lab. Okay, so the lab is going to consist of this. We're going to take a couple of battery-powered carts out to the atrium. We're going to run them along the atrium floor, measuring where they are, that is their position, every 5 seconds for 40 seconds. Okay, and we'll come back after we've gathered that data, and we will build position versus time graphs of that, and then there will be some analysis that will go on. That analysis may not make a whole, well, actually for you guys it will, because you've done the y equals mx plus b stuff before, so it will make sense, but we'll talk more about position versus time graphs on Friday, so that you can do the explanation part of the analysis on that day. Don't pack up yet, guys, we still got time. Okay, so tomorrow we'll have the Chromebooks. Okay, we'll be doing some measurements, and we'll be, getting as much of a lab report done as we can. Okay, and then Friday we'll talk more about the graphs. Monday, probably more stuff about graphs. Graphs are kind of big. Okay, middle of next week, we'll be doing another kind of lab activity. Okay, things like that. So it's going to be busy here for the next little bit. Now, in terms of your plant projects,